Welcome back guys to another video. Just like to start off this video by saying please look at the video description. There will be a link there to another video where you can find the answers to the questions that I give you at the end of this video. So today we're going to be looking at simultaneous equations, and in the past I've demonstrated how to solve simultaneous equations by the substitution method. Here I'm going to show you how to solve them using the elimination method. So let's start off with a quick recap. If we have y equals x plus 4 and y equals 2x plus 3, in previous videos I said that you can substitute this value of y in for this one here and have x plus 4 equals 2x plus 3, subtract x off both sides, and then subtract 3 off both sides, and you're left with x equals 1. Substitute that into here and you'll get that y is equal to 1 plus 4, which is 5. So that's what we've done in the past. Now there's another approach to solving simultaneous equations. It's called the elimination method. I think this is probably the method that people are normally taught first, and despite it being taught first, I think it's usually the method that people make the most mistakes on and they're least comfortable with. So let's start with these two equations once again. So I'm labelling the equations, they're number 1 and 2. Okay, well, if you wanted to eliminate a variable here, you could eliminate the y's because you have the same number of y's. You have 1y here, 1y here. You don't have the same number of x's, so it's a little bit more difficult to eliminate those. So what you can do here is you can simply do equation 2 subtract equation 1. Now if you do equation 2, on the left hand side you'll have y subtract y, which is 0. On the right hand side you'll have equation 2 subtract that, so you'll have 2x minus x, which is x, and you will have 3 subtract 4, which is minus 1. Then once you have this, you can simply add 1 to both sides and you'll have x equals 1. Then substitute this value in and you'll get y equals 5, the exact same as this. Now you can do equation 1 subtract equation 2, but it's not quite as nice to work with, I don't think. This is what happens if you do it the other way. Equation 1 subtract 2, so the left hand side will be y subtract y, which will be 0. The right hand side will be x subtract 2x, which is minus x. 4 subtract 3 is plus 1. Plus 1. Then you add x to both sides. You get x equals 1. Substitute that value in, you get y equals 5. Just a quick note here, folks. This kind of error here, where I said 4 subtract 3 is equal to 1. I said 1, but I still wrote down 3. Be careful of things like that. But at the end of the day, in an exam, you're going to be writing down hundreds of numbers. At some point, you're likely to make a mistake. So try not to beat yourself up about making mistakes like this too much. Just always try and focus. So why do I say this method, isn't quite as neat as this one? Well, I think it's good practice to try and keep the x positive. So here I decided to do equation 2 subtract equation 1 because the x in equation 2 was higher than the x in equation 1. 2x is higher than x. Now a lot of people aren't very confident here with subtracting equations like this. Instead, a lot of people want these written in a slightly different format, so maybe they are more comfortable with equations being written as y minus x equals 4 and y minus 2x equals 3. So I think a lot of people prefer their equations written like this, but you can do that yourself. You can just rearrange these equations to fit any form that you want. Now once you have this set up here, I'm going to call these equation 3 and 4. Okay, the same thing here. You can do equation 4, subtract equation 3 if you want, or you can do it the other way around. I'm just going to do it this way. So you're going to have y subtract y, which is 0y, or just 0, minus 2x minus x, that will become a plus, so minus 2x plus 1x will be minus x. 3 subtract 4 is minus 1. So here we have minus x equals minus 1. You can times both sides here by negative 1, they will both become positive, so x is equal to 1. And then you can substitute that into one of your equations there, and you'll work out that y is equal to 5. So there is an example of using the elimination method. Let's have another attempt at a different example. I'll use a fresh piece of paper. Let's try x is equal to 2y plus 4. X is equal to 3y minus 1. Okay folks, same thing here. Label your equations. Say we're going to do equation 2 subtract equation 1. Why are we doing equation 2 subtract equation 1? Well, because if we do this equation subtract this one rather than the other way around, we have 3y minus 2y, so that will remain positive. If we did equation 1 subtract equation 2, that would be 2y minus 3y, which would be negative. So try not to have negative numbers if you can, although it's not possible all the time. So equation 2 subtract equation 1. So the left hand side will be x subtract x, which is 0. The right hand side will be 3y subtract 2y, which is y. And then negative 1 subtract 4, which will be minus 5. So y is equal to 5 there if you add 5 onto both sides. Then you can substitute this in up here to calculate the value of x. 2 lots of y, well y is 5, so that's 2 lots of 5, 10 plus 4 is 14. And then always substitute these two values into your other equation, just to make sure there that you're making that these answers agree with each other. So 3 lots of 5 will be 15, minus 1 is 14, that's what we expect. So yeah, that's fine. Maybe here they didn't give you the question looking like that. Maybe it was minus 4 is equal to 2y minus x. 1 equals 3y minus x. Maybe they gave it to you like that. Okay, same thing, you can just subtract these equations. Minus 4 subtract 1 is minus 5. 2y subtract 3y is minus y. Minus x minus minus x is minus x plus x, which is 0. So y is equal to 5. Just the same answer that we got earlier on. And then you can substitute that in, and once again you'll work out that x is equal to 14. So that's that example there. Let's take a look at another example. Y minus 2x equals 4. 3x equals y plus 1. Okay, I'm going to invite you here to pause the video, have an attempt at that, and then unpause the video and we'll go through it together. So the best of luck to you there if you're attempting that on your own. Okay, so what do we do here then? Well, the y's are the same, there's one y there. So I'm going to rewrite this second equation here slightly, just so that it agrees, so that it mirrors the top line a bit clearer. I'm going to write it as y plus 1 equals 3x. So all that I've done here is change what's on the right hand side to the left hand side, and vice versa. So here you have equation 1 and equation 2 here. Okay, well, we can just subtract them. We can do equation 1 subtract equation 2. I've not chose the order there for any particular reason. That's just random. So the left hand side will be y subtract y, which is 0 lots of y, minus 2x minus 1, so minus 2x minus 1 is equal to 4 minus 3x. Okay, where have all these numbers come from here, you may be asking? Well, equation 1 subtract equation 2. The right hand side of equation 1 is 4. The right hand side of equation 2 is 3x. So equation 1 minus equation 2. Equation 1 minus equation 2. Then we can add 3x onto both sides and we'll be left with x minus 1 equals 4. Add 1 to both sides, x equals 5. And then you can substitute this value into one of our equations here and you can work out the value of y. Well, how do you go about doing that? Well, you say y minus 2 lots of our value of x, which is 5, equals 4. So that means that y is equal to 4 plus 10, which is 14. And then it's good practice then to use both of these here, sub it into the other equation, see, does it make sense? So that would be 3 lots of our value of x, which is 5, should be equal to 14 plus 1. So that's 15, that's 15, yeah, both sides agree with each other. So our value there, our solution, sorry, x equals 5, y equals 14 is almost certainly correct. Let's take a look at another example. I've kind of run out of paper here, just 1 second. Okay, I'm sorry about that break there. I ran out of paper. So, this here is our next question that we're going to take a look at. Again, pause the video, see if you can try it. The first thing that you could do is try and solve it using the substitution method, and then try and solve it via the elimination method. Okay, well this example here, using the elimination method, it's a little bit different to the examples that we've just looked at. As you can see here, y and 2y, minus 2x, 6x, nothing is the same there on both on both equations. So you need to make them the same. So we can get the y's to be the same just by timesing this whole equation here by 2. So 2 lots of equation 1 would be, so you just times everything by 2. That would be 2y minus 4x equals 8. And then, so that would be 2 lots of equation 1. Equation 2 would still be 2y plus 2 equals 6x. And then what you can do then is you can subtract these. You can say, okay, well, I'm going to do 2 lots of equation 1, subtract equation 2. 2y subtract 2y is 0 lots of y. Minus 4x minus 2. 8 subtract 6x. And then here now we can add 6x onto both sides and we are left with 2x minus 2 equals 8. Add 2 to both sides and you are left with 2x equals 10. So x is equal to 5. Divide both sides by 2. Once you have this, what you can do then is you can substitute it into one of these equations up here. So let's substitute this into equation 2. 6 lots of x is equal to 2y plus 2, so that's 30. Subtract 2 off both sides, so that's equal to 2y. That there is 28 equals 2y. Divide both sides by 2, you get y equals 14. So our solution there is that x is 5, y is 14. Now in this example here, I eliminated the y values. You could also eliminate the x values as well. How would you do that? Well, we would take, excuse me, if we wanted the x's to be the same, then we're going to need to times this by 3. So 3 lots of equation 1, which would be 3y minus 6x is equal to 12. And equation 2 is still 6x equals 2y plus 2. So here we wouldn't subtract these equations, we would add them. And the reason why we would add them is because minus 6x plus 6x will be 0x. Okay. So 3 lots of equation 1 plus equation 2. Here we have 3y add no y's, so that's just 3y. Minus 6x plus 6x is 0x. On the right hand side, 12 plus 2 is 14, plus the 2y. Now once we have this here, subtract 2y off both sides of the equation and we are left with just y equals 14. Then again you would substitute this value into one of these equations and you would calculate that x is equal to 5. The answers don't change regardless of how you decide to work this out. You know, if you would have changed this equation 1 here so that it was y equals 2x plus 4, and then you use that as a substitution here, so you would have had 6x equals 2 lots of y, and then you know if you expand that out, 4x plus 8 plus 2, subtract 2x off both sides, subtract 4x off both sides, you have 2x equals 10. Divide both sides by 2, x is equal to 5. As you see there, you get the same answer. You should always get the same answer regardless of the method that you use. So what I'm going to do now is I'm going to give you here some questions to try on your own. I just googled simultaneous equations and this is what came up. So have a go at solving these. I would recommend that you try and solve these using both methods, the substitution method as well as the elimination method. And when you do the elimination method, try and eliminate the values of x and then do it again and try and eliminate the values of y. Okay, so that way there you're practicing everything. Like I said at the start of the video, please check the video description. I will upload another video of me quickly solving these. It won't be as slow as this video. I will literally just go through them one at a time. So thank you very much for watching. If this is helpful, then please share the video. If you have any topic suggestions, then please do get in touch with me and let me know what you'd like to see. And yeah, that's everything for now. Thank you very much for watching. Have a good day.